Hi all. Today we are going to discuss about the representation of a graph. Last class we discussed about the adjacency matrix representation. Today we are going to discuss about adjacency list representation. A graph of n nodes is represented by a one-dimensional array L of a linked list, where L of I is a linked list containing all the nodes adjacent from node I, and the nodes in the list of I are in no particular order. I will explain these definitions or these statements with the help of an example. Before that, I just want to discuss about adjacency list or the adjacent elements. What are the adjacent elements in the case of a graph? In this case, adjacency list, for each vertex V from this set of vertex capital V, store a list of vertices adjacent to V. For example, adjacent vertices of 1 are 2 and 3 because there is a direct connection or a direction pointing to those nodes. For example, 1 is a node and the adjacent nodes of 1 are 2 and 3 because there is a direct connection. For the case of 2, we have only one adjacent node, that is 3. So because there is only one edge pointing to 3. And for example, for the case of a 4, number 4, the node 4, we have only one edge that is connected to 3. So 3 is the adjacent node of 4. For the case of 3, we don't have any adjacent nodes. So the adjacent nodes of 3 are empty. No elements are available. So here adjacent node of 1 are 2 and 3. Adjacent node of 2 are 3 alone. Adjacent node of 3 is empty. Adjacent node of 4 is 3. So we can say it's only because of the directions mentioned in the graph. There are some graphs without any direction, that is undirected graph. If so, the cases are different. So we are going to discuss about the implementation of a graph or implementation of adjacency list in the case of a graph. In this case, we have 4 vertices A, B, C and D, and A to B weight is mentioned on the edge 8. And from B to C the weight is mentioned 9. A to D weight is also mentioned, that is 6. So these are the list of elements available, and all the edges with weight also mentioned in the graph. And next step is to represent this graph in the form of a list. Okay. So now we are going to discuss about the statements that we mentioned in the slide. A graph of n node is represented by a one-dimensional array L of linked list. So that is the first step. We are going to mention all the elements in an array. So this is the thing. A, B, C, D are the list of elements and is mentioned in the array. And now we are going to find out the adjacent nodes of A. Adjacent nodes of A are B and D. We are representing this graph with the help of a single linked list. That is the next statement. L of I is a linked list containing all the nodes adjacent from node I. Here, from A, we have 2 adjacent nodes B and D. So I am choosing the alphabetical order. So B first and then D. You can choose any order. It's not an issue. You can choose either B first also, or either B, or you can choose D. It's up to you. So I am choosing B first. So in this single linked list, 2 data field and 1 address field is there. First data field contains the name of the node. Second data field contains the weight of the node, a weight from that particular A to that particular node, and the address field contains the next the address field of the next adjacent node. So for the case A, I am choosing B as the adjacent node, and the name of the node B is mentioned here, and the weight also mentioned here, and address field contains the next adjacent node's details. Okay, next adjacent node name is D, its weight is 6, and the address field is null. There is no more adjacent nodes available, so the address field is null. Likewise, in the case of B, we have 2 adjacent nodes A and C. A is the name of the node. The weight for from B to A is 8, and the address field contains the address of C. So name of the node is C, and the weight of the node is from B to C is 9, and the address field contains null because there is no more further elements and no more further adjacent nodes are available. For the case of C, only one element is available, that is B, and the weight mentioned on the edge is 9, and there is no more adjacent nodes, so address field is null. For the case of D, only one adjacent node, that is A, and weight from D to A is 6. So name of the node is A, the weight is 6, and the address field is null. So address field is null because there is no further element, no further elements available for D. So this is the way that we are representing graph in a form of a adjacency list. Thank you.